Welcome to Labster. In this simulation, you will learn all about the water cycle. Together, we'll investigate how water on Earth continuously moves between different stores and explore how human activities impact the cycle. This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top right of your lab pad to switch the play mode. If you disable the sound effects, the lab pad will slide up whenever there are instructions to read. You can select what type of audio you prefer. Deselecting any of the options will mute that option. Click Continue to learn how to navigate through your mission. Using the lab pad is an important way to get the most out of this simulation. Is this the first time you are playing a Labster simulation? Perfect, then let's get started with your first mission.
Hello, nice to meet you. I'm Max, a property developer from a nearby town. I'd like to build some new homes for the local people on this forested land. As you can see, there is a beautiful river right next to it. I've been told that developing on this land might affect the water cycle and cause problems like river flooding. Unfortunately, I do not know much about the water cycle. It would be great if you could help me learn more about it.
It looks like Max needs our help. When you are done having a look around, let's head to the lab to learn more about the water cycle. Welcome to the lab. Let's get started by learning about the water cycle. Head to the main room. Click on the doors to enter the main lab room. The water you drink every day is billions of years old. Yes, that's right. You may be drinking water that was drunk by a T-Rex, or was once part of a glacier in the Antarctic. But how exactly does water move around the Earth? Let's explore. First, let's look at the different kinds of water stores. All water on Earth is either saltwater or freshwater. Saltwater is found in the Earth's oceans, while freshwater is found in terrestrial stores, such as lakes, rivers and glaciers. Have a look at the wall display for more information. Move to the wall display. The water cycle is a vital part of life, as organisms are made up of mostly water. Even you're about 70% water. The display shows 5 water stores. Can you identify them all? Let's start with a store of saltwater. Pick up a pin from the box on the table and place it on a store of saltwater. That's right. Did you know that about 97% of Earth's water is found in the oceans, making it the largest store of water? Only about 3% of Earth's water is freshwater. Of that, roughly 1% is usable to humans as drinking water, as most freshwater is locked for many thousands of years in ice caps, glaciers, permafrost, and deep underground. Let's now explore other stores of water. Pick up a pin from the table and place it on a store of freshwater. Don't worry about placing pins in the wrong place. I'll be here to help you along the way. Nice. 0.001% of the Earth's water is stored in the atmosphere in its gaseous form of water vapor. The sun's heat causes water to evaporate and rise in the atmosphere. As it rises, it cools, which causes water vapor to condense into liquid droplets, forming clouds. That's correct. Most of the Earth's freshwater is contained within cryospheric stores. Cryospheric water is a term used to describe water stored in frozen form. Cryospheric stores may store water for many thousands of years in the form of glaciers, permafrost, ice caps, sea ice, and more. Nice. Lakes, rivers, and streams are examples of terrestrial water stores. Terrestrial water refers to water that is on the surface or subsurface of the Earth. Some cryospheric water stores, such as glaciers and mountain ice caps, may also be terrestrial. Exactly. Water can be stored underground as groundwater between soil and rocks. Groundwater is also referred to as the saturated zone because all of the spaces between the grains of soil and rock are filled with water. Groundwater defines the water table, which is a boundary between the saturated and unsaturated zones. Great work, you've identified the different stores of the water cycle. Which store holds the largest amount of freshwater? Absolutely, around 70% of the Earth's freshwater is stored as cryospheric water. The ocean is the largest water store in the world, but not of freshwater. Great job so far. Remember, you can check out the Theory tab to revisit these concepts at any time. Max will definitely appreciate it when we share all of this interesting information about water stores. But before we get to that, let's also explore the processes in which water can move from one store to another. Click the processes below to learn more. Evaporation is the process of liquid water becoming water vapor. It occurs when the sun's radiation heats up the Earth's water stores. Transpiration refers to the movement of water through plants. Water from the soil is absorbed by the roots, which travels within the plant via the xylem. Water exits through the stomata in the leaves where it evaporates. Water vapor cools when it rises up the atmosphere, causing it to condensate into water droplets and form clouds. The droplets precipitate to the Earth's surface as rain, hail, snow or mist. When water is absorbed into the soil, the process is known as infiltration. Interception occurs when precipitation does not directly reach the ground, and is instead intercepted by things such as trees, leaves and rocks. This water may evaporate before reaching the soil, or it may slowly infiltrate the soil as it drips downwards. Surface runoff occurs when water does not infiltrate into the soil. This can occur after heavy precipitation when the soil gets too saturated with water. Surface runoff can also happen when man-made structures such as concrete surfaces prevent water from infiltrating the soil. Groundwater flow refers to the movement of water underground. Groundwater can flow from high to low elevation areas, but also from areas of high to low pressure. Well done with exploring the processes. Remember, you can check out the Theory tab to learn more about these concepts at any time. The water cycle doesn't have a beginning or end, as water is continually moving through the different stores. Pick up the cards in front of you and place them in the correct spot on the display. Bingo! In this process, after water vapor condenses, it falls as rain, sleet, snow, hail, or mist. Most water vapor is evaporated from the oceans, but some of this water precipitates over land and contributes to terrestrial water. That's right. Which statement describes infiltration? You are awesome. Infiltration is the movement of water into the soil. This process replenishes the store of groundwater, which raises the water table. Click on the lab pad. Awesome! Groundwater flow describes the slow movement of water stored underground. Which of the following is a true statement about groundwater flow? Brilliant! The flow of groundwater depends on pressure as well as elevation. Yes. Interception is a process in which rainfall doesn't reach the soil straight away. It gets intercepted by leaves, tree canopies, leaf litter, and more. It may evaporate before reaching the soil or slow down the rate of infiltration. Things like forest fires or deforestation can negatively impact the rate of interception. Transpiration is the movement of water through plants. Plants uptake water from the soil through their roots. The xylem and veins transport water throughout the plant. Water exits the plant through small pores in the leaves known as stomata, which is also where gas exchange occurs. Absolutely. When the rate of precipitation exceeds the rate of infiltration, this leads to surface runoff. Flooding occurs when surface runoff is too much for streams or rivers to contain. Forests decrease flooding by increasing interception and decreasing runoff. Absolutely. The sun's radiation is vital for evaporation. During this process, water evaporates from the surface of oceans, soils, and other terrestrial water stores. There is also a special kind of evaporation known as sublimation where solid water, such as ice, is converted straight into water vapor, bypassing the liquid phase. You got it. As water vapor from evaporation rises into the atmosphere, it begins to cool, causing it to condensate back into liquid droplets that form clouds. Great work! You have learned all about the different water stores and processes which make up the water cycle. You see, the water you have drunk today has been cycling around the Earth since before life began. Who knows how many organisms it has passed through or how many different stores it has been a part of. These processes can be influenced by human activities, such as urban development, deforestation, and pollution. Now, let's look at how Max's property development may impact the water cycle. Move to the 3D model on the holofloor. Max's property development will involve removing trees and replacing them with impermeable surfaces, like concrete. What effect do you think this will have on the rate of infiltration and interception? Let's test your hypothesis. The 3D model shows the forest we were in earlier, but it is split into 9 plots. Clicking on a plot will convert it from forest to housing. When you click a plot once, it will convert the plot to sustainable housing. This type of housing can house 50 people per plot, and it is designed to have a smaller negative impact on the rate of interception and infiltration. If you click the plot again, it will be converted to standard housing. Standard housing can house 100 people per plot, but it has a bigger negative impact on the rate of interception and infiltration. Let's start by building a small village. The scale shows the current rate of interception and infiltration. This will change as you start building. Use the blue arrows to rotate the model and the blue magnifying glasses to zoom in and out. Once you have reached the population goal, click the cloud to test your model. Build enough housing to reach the village population goal. Awesome, you have achieved the goal without causing too much disruption to the water cycle. Would you like to play again? Hopefully, you were able to see that a small amount of development is unlikely to significantly increase the risk of flooding. However, Max is looking to build a town large enough to house at least 350 people. Let's see if it is possible to build a town. Build enough housing to reach the town population goal. Awesome, you have achieved the goal without causing too much disruption to the water cycle. Would you like to play again? Through modeling, we have tested your initial hypothesis and determined that removing trees and replacing them with impermeable surfaces decreases the rate of interception and infiltration. This is because there are fewer trees to intercept rainfall and impermeable surfaces block rainfall from reaching the soil. We have also demonstrated that a higher rate of infiltration and interception results in less surface runoff and flooding. This is why it is important to analyze how infiltration and interception are affected by human activities such as property development. But, why does an increase in interception cause a decrease in surface runoff? That's right, intercepted water either evaporates or slowly falls to the soil. As well as this, an increase in infiltration can also decrease runoff because more water is absorbed into the soil, rather than flowing over the land surface. Lastly, how do impervious surfaces, like concrete, impact the rate of infiltration? That's right, water in urban areas is mostly captured by drainage systems, which typically redirect water to waterways rather than the soil. Surface runoff that occurs in an urban area is known as urban runoff. Let's tell Max about what you have found out. He's heading into the lab via the doors on your left.
Thank you for all of your hard work. It looks like if I build too much in this area I may cause the river to flood. I will be mindful of this and make changes to my current plan.
Great work. I hope you have had fun learning all about the water cycle. Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation? Thank you for your feedback. Your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.